Hello everyone, thanks for joining today's class. Today we'll be discussing on calculation involving stoichiometric equation. Stoichiometric equations are the balanced chemical equation showing the appropriate numbers of moles of the reactant and products involved in the reaction. It's also possible to calculate the mass or volume of the gaseous reactant or gaseous products involved in the reactions from the balanced equation. Now let's see what's on the board. First thing to do is to balance the equation. And when we are balancing the equations, we have to look at what is given to us, calculate the mass of ammonia produced. When you are told produce, it means that at the product side, we have the ammonia. When 11.2 cm cube of nitrogen gas reacted with excess hydrogen gas, that means the reactant is nitrogen gas and hydrogen gas. Now you're having nitrogen gas, it's a gas, plus hydrogen gas to give us ammonia from the question, from the statement, ammonia produced. Now I want to know how the hydrogen is XX. You can see it. We have two nitrogen here. After we balance the equation, we are going to confirm for us that it is XX. Now have two nitrogen at the reactant side, balancing with 2. When you are balancing with 2, now hydrogen at the product side has become 6. 2 times 3, 6. You now add your 3 here. That's form 3 moles of hydrogen. Now you now have 1 mole of nitrogen, 3 moles of hydrogen, and 2 moles of ammonia. You can see that based on the mole, you can see that hydrogen is now excess. We are looking at it, 3 greater than 2 and greater than 1. Now let's go to Gay-Lussac's law of combining volume. You have 1 mole, that's 1 volume, 3 moles, 3 volume, 2 moles, 2 volumes. And volume can either be expressed as centimeter cube or meter cube. But we're going to express it as centimeter cube because in the equation, we are given 11.2 cm cube of nitrogen gas. Because of that, we now write 1 cm cube. Cm cube stands for volume. 3, we don't need to express this as cm cube because we are concerned with nitrogen and ammonia. 3 moles of hydrogen is only telling us that it's in excess. But you have 2 cm cube here. Please don't forget, when you are solving a problem under stoichiometric, you relate the volume with the volume you have in the equation. Okay? You're having 1 cm cube of nitrogen gas is a molecule, N2 produces 2 cm cube of what? Ammonia gas. Now go to the question, 11 cm cube of nitrogen gas. 11 cm cube of nitrogen gas produces what? 11, we cross and multiply. 11 cm cube times 2 cm cube divided by 1 cm cube. Cm cube cancels cm cube. Now I have 11.2. Sorry, this is 11.2 And see from the question, 11.2 cm3 11.2 produces 11.2 cm3 times 2 cm3. Cm can cm3, we are having 22.4 cm3 of ammonia gas. Okay, when you have it like that, please don't forget that we are going to look for the mass of molar mass of the ammonia, molar mass of the ammonia, ammonia gas. You have nitrogen to be 14 plus 3 times, you have 3 of hydrogen times 1, which is 14 plus 3, which is 17 gram per mole. The molar mass is expressed as gram per mole. Please follow BODMAS, multiplication before addition. Okay? There'll be some cases in which when you do like in this case now, when you say 14 plus 3, which is 17, 17 times, we still give you 17. We have some cases that it can't work, it won't work. Let me say you're having 1, 2 at the number, you multiply with this 3, say 14 plus 3 times 2, for example. When you say 3 times 2, the normal way of doing it, following board mass, that's 6 plus 14, that's 20. But if you do it in the wrong way, 14 plus 3, 17, 17 times 2, see, 34. This one is wrong. It's the correct way, following the board mass. Now, you will now relate the gram molar volume of the gas to the molar mass, the standard molar mass of the ammonia. Please, that's what you need to do. But you can see the gram molar volume of the gas at S.T.P is in decimeter cube. You have to convert it to centimeter cube because we are working in centimeter cube. Okay, 1 dm is equals to 10 cm, 10 centimeter. Now, 1 dm cube is 1 times dm times dm times dm. Sorry, okay. And because to 1 time, what's our 1 dm is 10 centimeter, 10 centimeter times 10 centimeter times 10 centimeter, which is when you multiply, you're having 1000 cm cube. Tell me that 1 dm cube is equivalent to 1000 cm cube. Now go back to what we have, 22.4 dm cube equals to 22.4 times 1 dm cube, which is equals to 22.4 times 1 dm cube is equivalent to 1000 cm cube, 1000 cm cube. Equals to, let's change it to fraction in case you don't have calculator to multiply. 224 divided by decimal stand as 1. 4, how many figure after decimal? That's 1 times 1000. 0 comes 0. It's now 22,400 cm cube. Okay, converted it. Now, you now say 22, which is the standard, 22,400 cm cube, which is the GMV of the gas at S.T.P. Now say 22,400 cm cube of ammonia gas, 1 mole of ammonia contains what? 17 gram per mole of ammonia gas. This is the mass. We relate the standard with the standard. Now before you relate this, Let's know what 1 centimeter cube will be equal to. 1 centimeter cube of ammonia gas contains, want to make it standard. That's why we say 1 centimeter cube contain what? 1 times 17, that's 17 over 22,400. I'll say it, 1,400, 1 times 17 divided by 2,400 is now in gram of ammonia gas. Okay, we need it. We have to calculate the mass of ammonia gas produced. Since we have to look for the mass of ammonia gas produced, the second expression will be in gram. After you have written it as 1 centimeter, 1 times 17 divided by 22,400. Now, this is gram equivalent to 1 centimeter cube of ammonia gas. We now go back to the equivalent of 11.2 cm of nitrogen that give us um, that give us that give us 22.4 cm cube. You can see 11.2 cm cube produces 22.4 cm cube. Okay, since we need the mass of ammonia, that's why we have to use this. Now, we are not using 11.2 cm cube again. 11.2 cm cube has given us, has produced what we need. All right, um, 22.4 cm cube of ammonia gas contains 22.4 times 17 over 22,400. Okay, don't forget this centimeter cube, 2.4 centimeter cube times 17 over 22,400 gram. You see it, divided by 1 cm cube, which is equals to 22.4 cm cube times 17 over 22,400 gram is over 1. When you change the multiplication, 1 will go up, 1 cm cube will come down, cm cube cancels cm cube. We are left with 22.4 times 17 divided by 22,400, which is equals to, when you multiply the numerator, you have in 380.8 divided by 22,400, which is equals to 0.017 gram of ammonia gas. Okay, can I write a statement? As a statement, can I write that the mass of ammonia produced when 11.2 cm cube of nitrogen gas is reacted with excess hydrogen gas is 0.017 gram of ammonia gas. That brings us to the end of the class. Please don't forget to subscribe to the channel for more updates. And also don't forget to leave your question in the comment section. Thanks for watching. See you in the next class. Have a wonderful day.